welcome to Math Advice. In this video, let me explain odd and even functions under Fourier series. For that, I am going to expand. The function is defined here as two subintervals in from minus pi to pi. That is minus pi to 0 takes 1 plus 2x divided by pi, whereas 0 to pi the function takes a value f of x takes a value 1 minus 2x divided by pi. So let me first find the Fourier series representation of the given function defined in a range minus pi comma pi, and then we have to deduce this given series, right? So before that, let me move into the important formulas that we are going to use in the given problem to find the Fourier series representation of the given function f of x. Suppose inside the integration, if you are having the product of two functions and also these two functions are functions of x, then how to evaluate that integral? For that, we make use of this formula. This formula is known as Bernoulli's formula. That formula is integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. Here u double dash represents the derivatives of u. That is, u dash is nothing but first derivative of u. That is du by dx. U double dash is nothing but d square u by dx square. That is the second derivative of u. Likewise, u triple dash means d cube u by dx cube, etc. So u dash, u double dash, u triple dash are successive derivatives of u, whereas v1, v2, v3, etc. are successive integrals of v. Here v1 is nothing but you have to integrate v once with respect to x, that is integral v dx. That is your v1. v2 is nothing but you have to integrate v two times with respect to x. Instead of doing like this, already we have v1. So you have to integrate v1 once again with respect to x, that is your v2. Next, v3 is nothing but integrating v 3 times with respect to x. So instead of doing like this, already we have v2. So you have to integrate v2 once with respect to x, that gives you v3, etc. So v1, v2, v3 are successive integrals of v. And the next thing, basic formulas of integration and differentiation, as you know already, that is integral x bar and dx is equal to x bar n plus 1 divided by n plus 1. Whereas if you are differentiating the same function, you get nx power n minus 1, and the integral sin x dx is nothing but minus cos x, and the integral cos x dx is nothing but sin x. So in general formula, integral sin nx dx is nothing but minus cos nx divided by n, whereas integral cos nx dx is equal to sin nx divided by n. And the basic limit values of cosine and sine for the values of at 0, pi and pi. So these are all the values you know already, isn't it? Cosine 0 is 1, whereas sine 0 is 0. Cos pi is minus 1, whereas sine pi is 0. Cos n pi in general minus 1 whole power n, whereas sine n pi is equal to 0, and n takes an integer value. Here most probably we take only integer value. So whenever you see n pi, you just put 0. Okay. Now let me enter into the given problem. So expand f of x is equal to 1 plus. Now just I write the function here. So as I told you already, whatever may be the given problem, you have to first write down the function along with the interval. That is must. Okay. So f of x is equal to, instead of the function defined in a whole interval minus pi to pi, it is defined in two subintervals. That is in from minus pi to 0, it takes one value. So 0 to pi, f of x takes another value. So from minus pi to 0, it takes a value 1 plus 2x divided by pi. Whereas from 0 to pi, the interval 0 less than or equal to x less than or equal to pi. 0 to pi, it takes a value 1 minus 2x divided by pi. Look at the interval. The interval is from minus pi to pi. Okay, this is the lower limit and this is the upper limit of the interval. So the interval is from minus pi to pi. As I told already, the case of odd and even function arise only for the intervals of type minus pi comma pi and minus l comma l. And the case of odd and even function doesn't hold for the intervals of type 0 comma 2 pi and 0 comma 2l. So look at our problem. The problem is from, that is the function takes the values from minus pi to pi, which means we are under odd and even functions. Okay, so that means you have to immediately verify whether the given function f of x is even or odd. So as you know already, I am just giving you a short introduction about how to find the given function is of odd and even. So you know already the function f of x is defined, whatever may be the given function, if it is defined in an interval minus pi comma pi, that is as a whole range. So you know how to find whether the given function is even or odd. That is, if you replace x by minus x in a given function, if you get the function itself, means the given function is an even function, isn't it? Suppose if you replace x by minus x in a given function, if you get minus of f of x, means that is an odd function. So these are the cases you know already. Here, instead of defining the function in a whole range, suppose the function is defined in two subintervals like this, minus pi to 0 and 0 to pi. Okay, so here the function is defined from the full range, that is f of x takes a unique value from minus pi to pi. But instead of defining like that in minus pi to pi, so suppose the function takes the value two different values in two subinterval like this, then how to find whether the given function is of odd and even? So that's what I am going to explain. Suppose the first function given is, let me take that as pi 1 of x, the second function as pi 2 of x. Okay. So what you are going to do is, so now you have to replace in the first function x by minus x, that is pi 1 of minus x. You will see, if you replace x by minus x in the first function, suppose if you get the second function as it is, that is a pi 2 of x, which implies the function f of x is an even function. Okay, if pi 1 of minus x gives you pi 2 of x, if you replace x by minus x in the first function, you get the second function as it is given in the problem, means the given function is an even function. So which we come to the conclusion that f of x function is an even function. Suppose if you replace x by minus x in the first function, if you get minus of the second function, that is pi 2 of x, which means the function f of x is odd function. So if it is so, we come to a conclusion that the given function is of odd type. Okay, so let me give a short introduction about that. So now let me move on to the given problem. So look at a given problem. So this is a function is defined here itself, two subintervals. So what I am going to do is, what is your pi 1 of x? The first function is your pi 1 of x here. So pi 1 of x is nothing but 1 plus 2x divided by pi. And your pi 2 of x is nothing but your second function. What is your second function? This is your second function, isn't it? 1 minus 2x divided by pi. Now let me check what happens when you replace x by minus x in pi 1 of x. So if you replace x by minus x in pi 1 of x, here itself you have x term. So 1 plus 2 of minus x divided by pi. That is nothing but 1 minus 2x. I am just write this as 1 minus 2x divided by pi. What is this 1 minus 2x divided by pi? That is exactly your second function pi 2 of x. So you get, if you replace pi 1 of minus x, that is x by minus x and pi 1 of x, you get pi 2 of x. What it means? Therefore, the given function f of x is an even function. If it is an even function, what it means? The value of bn becomes 0, isn't it? So let me show you the formula table for your understanding more clearly. So leave this interval, because now we are under the interval of type minus pi to pi. So in minus pi to pi we have three categories, right? Either it is of even, odd, or neither even nor odd. So now we are under this category. So the given function is of even type. So if it is of even type, we calculate only a not a. So no need to calculate the value of bn. So bn value directly becomes 0. So the Fourier series representation of the given function is of the form f of x is equal to a naught divided by 2 plus sigma n, which is from 1 to infinity a n cos n x, where a naught is equal to 2 pi pi integral 0 to pi f of x dx, and a n is equal to 2 pi pi integral 0 to pi f of x cos n x dx. So by making use of these two formulas, we calculate the values of a naught, a n, and substitute an equation gives you the Fourier series representation of the given function f of x. Let me first calculate the value of a naught. So for that, what I am going to do is just replace your next step, replace f of x by given function. So listen, I am just write down the function once again. So what is the given function? F of x is equal to 1 plus 2x divided by pi and 1 minus 2x divided by pi. So this is for the interval of type minus pi to 0, minus pi less than or equal to x less than or equal to 0, and this function is from 0 less than or equal to x less than or equal to pi. So here you have a confusion, which one you have to take? Look at the integral. So in the integral, so you have the limits from 0 to pi. 0 to pi is your second function, isn't it? In 0 to pi, f of x takes the value 1 minus 2x divided by pi. Okay? So don't take the first function because in 0 to pi, so function takes the value 1 minus 2x divided by pi. Okay? So 1 minus 2x divided by pi dx. So that is equal to, so this is basic integration. So you have to integrate now directly. So first one that is dx is nothing but x itself, minus 2 by pi is a constant. So if you integrating, what you get? You take 2 by pi is a constant. Integrating x with respect to x, you get x square divided by 2. That's all. So with the limit from 0 to pi. So that is equal to 2 by pi. I am just simplifying this before substituting the limits. So x minus x square divided by pi with the limit from 0 to pi. Now let me substitute the limits, right? So now a naught is equal to 2 by pi. So upper limit minus lower limit. So the first bracket is for upper limit minus the second bracket is for the lower limit. Okay, bracket is very important. So now first replace x by pi. What happened? Pi minus pi square divided by pi. Coming to the lower limit minus, if you replace x by 0, what happened? First term 0, also second term also 0. So there is no lower limit for this, isn't it? So that is equal to 2 by pi. Pi minus, so pi square means one of the pi p cancel, so pi minus pi. So what happened? Pi minus pi is nothing but 0. 0 into anything, 0. So the value of a naught here we calculated is 0. Next, we calculate the value of an. For that, we make use of the formula 2 by pi integral 0 to pi f of x cos n x dx. So here itself, that is equal to 2 by pi integral 0 to pi. In 0 to pi, f of x takes the value 1 minus, as I told you already, you take the second function, that is 2x divided by pi, because in this interval, f of x takes the value 1 minus 2x by pi cos nx dx. So here we have product of two functions, so you have to take u as 1 minus 2x divided. Here we have to use the Bernoulli's formula to evaluate this integral, isn't it? So you know already, integral uv dx is equal to uv1 minus u dash v2. So we have up to two terms, right? Now you have to take u as 1 minus 2x divided by pi and v as your cos nx. So u dash is nothing but first term becomes 0 because that's a constant. So differentiating constant, you get 0 minus 2x divided by pi. So you get only minus 2 by pi alone. X becomes 1. So next v1 and v2 alone we have to calculate. Suppose if you calculate the next derivative, what happens? U double as 0. So we have to stop up to this in the formula. Okay. So now we have to calculate v1 and v2. So v1 is nothing but integral cos nx dx. Integrating cos nx, what you get? Sin nx divided by n. And v2 is nothing but you have to integrate this v1 once again. So you have minus cos nx divided by n. Already you have n in the denominator here. So that becomes n square. So let me substitute in the formula 2 by pi u v1. Your u is 1 minus 2x divided by pi. And your v1 is nothing but sin nx divided by n minus u dash, that is minus 2 by pi, and your v2 is nothing but minus cos nx divided by n square with a limit from 0 to pi. So let me simplify first the symbols. So here you have 3 minus. So in the next step we will have substitute the limits. So first term, there is no change, write it as it is. Here you have 3 minus, so that so finally we have minus itself. So 2 by pi cos nx divided by n square with the limit from 0 to pi. So these are the places we have x term. So now let me first substitute the upper limit. If you substitute the upper limit, no. So you have an, that is equal to 2 by pi. So put a big parenthesis. So first bracket is for upper limit and second bracket is for lower limit. Now let me first substitute upper limit. So in the first term, look at here, that is sin n pi. You know the value of sin n pi. What is the value of sin n pi? The value of sin n pi is 0. So sin n pi 0 means the entire term becomes 0 for substituting pi. the first term becomes 0 because sin n pi is 0, isn't it? Minus 2 by pi cos n pi. You know the value of cos n pi. What is the value of cos n pi? Minus 1 whole power n. So you have minus of 2 by pi minus 1 whole power n divided by n square. Minus of 2 by pi minus 1 whole power n divided by n square. Next, coming to the lower limit, upper limit over minus lower limit. If replace x by 0, what you get? Sin 0. You know the value of sin 0. What is the value of sin 0? 0. So the first term 0. So the first term 0 minus, coming to the second, 2 by pi cos 0. Cos 0 value is 1. So 2 by pi 1 by n square, isn't it? So 2 by pi 1 divided by n square. Let me simplify this. Gives you the value of an. So 2 by pi minus of 2 times minus 1 whole power n divided by pi n square. Here the 2 minus becomes plus. So 2 divided by pi n square. So in both of these, 2 by pi n square is a common term. Take it outside. So if you take it outside, 2 by pi, you have to take 2 by pi n square as a common term and take it outside, isn't it? So you have minus of minus 1 whole power n plus 1. So what here you have? So 4 times divided by pi square n square 1 minus 1 whole power n. So this is the value of an we have calculated. Again we have to simplify this in terms of odd and even numbers. So what I am going to do is, you just replace the value of n by any one of the odd numbers. Odd numbers means either 1, 3, 5, whatever that may be. I am going to take the least value 1. If you replace n by 1, what happens? Minus 1. 1 minus minus 1. Minus 1 power 1 is minus 1 itself. So 1 plus 1, 2. So 4 2s are 8, isn't it? So multiply this with this value. So 8 divided by pi square divided, product n square. So when n is odd, what happens if you substitute even numbers? Suppose if you replace n by 2, minus 1 whole square, minus 1 whole square plus 1. So what happens? 1 minus 1. So you have 0. 0 into anything? 0, isn't it? So if n takes even numbers when n is even, so n take even numbers, an value becomes 0. So the value of an exists only for odd values, isn't it? So after calculating the values of a naught an, what we do? Let me substitute all these values in f of x. That gives you the Fourier series representation of the given function, isn't it? So your f of x is equal to, the value of a naught we calculated is 0. So first term becomes 0 plus sigma. Instead of 1 to infinity, you have to write odd term to infinity. So n is either you can write odd numbers to infinity, or you can write 1, 3, 5, etc. to infinity, whatever that may be. Okay. So an, the value of an we calculated is 8 divided by pi square n square cos nx. That's all. So your f of x is equal to, so here 8 divided by pi square is a constant. So take it outside of the summation. Sigma n varies from here. I am just write 135 to infinity cos nx divided by n square. So this is the Fourier series representation of the given function f of x defined in interval minus pi to pi. Then what we are going to do next is, we have to deduce a series from this. Okay, that is what we are to do next. So for that, so I am just giving you the problem for your understanding. So what from this problem, first one, what we did, we can find out the Fourier series representation of the given function f of x, that is nothing but 8 by pi square sigma n is equal to 135, that is odd terms to x infinity, cos nx divided by n square. So we have to find out, find the Fourier series representation of this function, and from that we have to deduce this series. Okay. So how to reduce this series? Look at the function here, cosine function. As I told you already, most of the cosine series are obtained by putting x equal to 0 or x equal to pi. So for under the topic convergence of Fourier series, I will explain these in detail. For more details, you refer the link. The link is given in the description box. Okay. So now look at here. We need sum of the series. Okay. So 1 by 1 square, 1 by 3 square, all are from plus plus plus. So what we have to do is put x equal to 0. Put x equal to 0. If you substitute x equal to 0, immediately you can verify whether that is a continuous point or discontinuous point. So x equal to 0 is in the interval, isn't it? X equal to 0 belongs to the interval. So x equal to 0 is which is a continuous point. Then the value of f of x at x equal to 0 is equal to 8 divided by pi square sigma n varies from 1, 3, 5 to etc. infinity cos 0. Here itself you replace x by 0 and here itself you replace x by 0. So at this question we calculate the function value at x equal to 0 and cosine 0 value you know already. What is the value of cos 0? 1 divided by n square. How to find the value of f of x at x equal to 0? I will show you the table for your clear understanding. So under the convergence of Fourier series, I have explained this concept in more detail. So if it is continuous function, what we do? We have to substitute the value directly. Okay, this is what we have to follow to find the value of the function at that point. So f of x at x equal to 0 means what is f of x at x equal to 0? Your f of x is 1 minus 2x divided by pi for the interval 0 to pi. So what we do here? So if you replace x by 0, what you get? F of x equal to 1 minus 0. Isn't it? Here 1. The function value at x equal to 0. Sorry, f of 0. So function value at x equal to 0 is nothing but 1. So f of x at x equal to 0 is nothing but 1 is equal to 8 by pi square sigma n is equal to 1, 3, 5 etc. to infinity 1 by n square. Let me keep this summation one side and take the remaining terms to other side, gives you the series, isn't it? So that is sigma n varies from 1, 3, 5 to infinity 1 by n square is equal to, and just take this term to other side. Keep this to one side and take this to other side, gives you 8 by pi square becomes pi square by 8, isn't it? Pi square divided by 8. So expand this series by substituting n equal to 1, 3, 5, what you get? So 1 by 1 square plus 1 by 3 square, next term 1 by 5. That is equal to pi square by 8. So this is what the series we have reduced, isn't it? That is also coincide with the given series in the problem. So up to this, hope you got a clear idea about how to find the Fourier series representation of the given function, which is given in two subintervals under minus pi comma pi. Thanks for watching. See you all again in my next video.